and welcome everyone to the Decentralized Energy from Waste webinar. In the next 45 minutes, we are going to share with you the technology of the small waste incineration plants. We are going to understand why sometimes getting small is better. And finally, we will go through a real case reference that both of our companies have in southwest of England, in Exeter. My name is Alex Mas. I am product manager on the thermodynamics division in Bianna, and I'm broadcasting from one of our facilities in Valencia. For me, it's a big pleasure to introduce you to my co-presenter, Alessandro Bertacchini. But before, I wanted to let you know that we are recording this session and you can leave the questions on the QA box. And at the end of the session, we will try to answer in the last 10 minutes as much questions as we can. So, Alessandro, welcome.
Thank you, Alex. Hi, everybody. First of all, let me say it's really great to be here with all of you. I'm very excited. A lot of exciting things line up. Definitely a few irons in the fire. Later on, hopefully, we will also have the chance to connect live with Greenbrook in Exeter, where he will give us a look at his power plant in action. So we will try to keep things efficient, focused, and as engaging as possible. I don't waste much time. Let's get rolling, Alex.
Okay, thank you, Alessandro. First, let me give a snapshot of Bianna. We've been the last 30 years engineering, constructing, and delivering waste solutions for the waste sector, from sorting and shredding plants to energy from waste systems as the one we are speaking today. In Bianna Energy from Waste, or as we like to call it, the thermodynamics branch, we are able to supply whole systems, well, without the civil, but the rest of the supply. We are able to do it from 15,000 tons per year to 150,000 tons per year to give electricity and or heat. So, Alessandro, can you tell us what is the TURBODEN side of story?
Sure. Well, TURBODEN is an Italian company with some 40 years experience. We are part of Mitsubishi EV Industries group, which holds a 51% stake in us. We are proud to be a global leader in renewable energy solutions. We help industries decarbonize and support the broader energy transition. Our product lineup includes large heat pumps, gas expanders, and of course, the topic of today, organic Rankine cycle turbogenerators. We specialize in designing, building, and maintaining ORC systems. Those systems generate electricity by converting heat from renewable sources like geothermal, biomass, but also industrial waste heat, and most relevant for today, waste fuel. We have over 400 installations worldwide, and our solutions ranges from 500 kilowatt electric up to 40 megawatt electric using a single shaft turbine. And well, that's about it. I mean, as well as Bianna, we are definitely passionate about delivering efficient, sustainable energy whenever is needed.
Yeah, this means that Bianna and TURBODEN, we can offer integrated package. Bianna can deliver from everything from basically full handling to flue gas treatment, and we can include or not the turbine, meaning that TURBODEN is able to supply the turbine independently, or it can be grabbed into the EPC mechanical electrical supply of Bianna. So, Alessandro,
Okay.
if you
Yeah,
want to go on.
let's start. Yeah, sure. Let's start. Now that we have covered the introductions, let's take just a moment to clarify what we actually mean by decentralized energy from waste plants. We are talking about facilities that process up to around 150,000 tons per year of non-recyclable waste. Well, the exact legal definitions may vary country by country. In the UK, for instance, they are known as small waste incineration plants, or SWIPs, if they burn less than 3 ton per hour. While in the EU, the focus is more on the thermal input, so the threshold is under 20 megawatt of thermal. Anyway, regardless of the regulation, the key idea is the same. I mean, those are local scale plants which are built close to where the waste is generated, and they are designed to serve a specific community or an industrial site. And here in this slide, we have identified four big reasons and contributions that those small plants have. First, well, the climate impact is quite common with all the energy from waste plants, because regardless of the size, big or small, they all help by diverting residual waste from landfills, which is crucial, we all know, because landfills release methane, a greenhouse gas that is about 80 times more damaging than CO2 over a 20-year period, and that's very well known. But let's say smaller local plants go even a step further, because they are cutting down also transport emissions, because less need to truck waste long distances means also less CO2 emissions. Of course, talking about sanitary contribution, the thermal treatment clearly plays a key role in public health. It helps eliminate vermin, prevents leachate from contaminating groundwater, destroys persistent pollutants like PFAS, and those are things that they are difficult to handle by mechanical recycling only. There is also the socio-economic benefit, which is highlighted here. And of course, being local, a small energy from waste plant helps to keep jobs and energy revenues within the community. Also, we will see later more in detail that the footprint of those small-scale systems is very compact. The stack height is lower than traditional energy from waste, and also the visual impact is minimal. And this often means greater public acceptance, and also dealing with local authorities. They have a faster planning and permitting process. So yeah, the energy contribution, of course, this one almost speaks for itself, I would say. With decentralized energy from waste systems, the owners can move towards energy independence. This system can run on local waste, and they turn it into electricity, heating, and yes, possibly even cooling. With a modular design, they can easily integrate into existing industrial setups for self-consumption, or they can be used to power remote mini grids, and they can provide stable, synchronous power, which is a really huge advantage, I would say, in area where the grid is not always reliable. Let's go to the next slide. Yeah, here we just want to give you a quick preview. That's a 3D cutaway of a decentralized energy from waste plant. Just a very quick preview of what we will be diving into next, more in detail. Even if we are talking about a small scale, you can see the setup is still similar to a traditional energy from waste layout. You have got fuel storage and dosing, moving rate combustion chamber, of course, flue gas cleaning, very important, and of course, also the power block with ORC turbine and air-cooled condensers. Well, the interesting thing is that unlike larger utility scale plants that are using steam, the difference here is that we use thermal oil as the heat transfer fluid. That's why you will notice in the picture here some components like oil pumps and expansion vessels. And that's the key difference. The key difference that makes the system more compact and flexible, as we will see later. So apart from the ORC turbine, also I would say the most of the innovation is in the patented Horizon Plus boiler, which is developed by Bianna. And yeah, I will let Alex talk a little bit about it.
Okay, thank you very much, Alessandro. I'm very happy to be able to present this in these webinars. This is what the webinars are for also, to present some innovations. So this is something that Bianna has been working in the last years, and it's related with the issue that every boiler and combustion of solid fuel manufacturer, designer, operator, maintainer have been dealing with. All of you know the issue in this kind of systems is the inerts, the impropers that are contained into the fuel, right? Especially fuels like RDF, which have from 15 up to 25% of these inerts into the boiler, right? These inerts, when the combustion starts, go into the flue gases stream in the form of ashes, causing different problems into the heat exchangers of the boilers. The main of them are lower performance and waste stops that cost a lot of money. And of course, abrasive and erosion, followed by a compressed gas cleaning, which has a very big self-consumption. Okay. Facing this problem, Bianna has developed and patented what we call the Horizon Plus boiler. When the Horizon Plus boiler, which is made of concentrical coils, get these ashes into the system, by means of its rotary movement, it gets the ashes out of the heat exchangers in real time, meaning that this movement makes all of the ashes go away. But even in case of sticky ashes, as you may know, some alkalis can provoke that we have very sticky ashes into the heat exchangers that are not easily removed. The system is able to introduce this low speed sandblasting system into the coils, which is completely harmless to the system and removes completely and on real time these ashes from the heat exchanger. What do we get with this system? Very easy. We get a system which doesn't need to be stopped and clean. It gets clean on real time, affecting on a positive way to the efficiency. Second, we don't have abrasive or chemical particles on the coils or the heat exchangers, so we avoid the corrosion. And then, of course, we are avoiding unwished stops and these parasitic loads caused by the compressed air. As everyone who operates a plant know how this how much this expensive is. Okay, so thank you for the chance to present you this innovation. This is an innovation, but it's also a mature product which is already installed in 2 plants in the UK, and of course we are happy to show it. So after this, I'm happy to give back the word to Alessandro so he can keep talking about ORC technology. Alessandro?
Sure. Thanks, Alex. Yeah, that's really fascinating actually to see this rotating horizon plus boiler. A bit of innovation is also in the application in employing for these decentralized waste to energy plants the ORC technology, which is very mature, of course, but it's an innovation in the waste to energy. The working principle of an ORC is actually quite similar to a traditional ranking cycle, but with one big difference. There is no water involved. Instead of water, we use a specially selected organic fluid, selected based on the specific needs of each project. The fluid runs in a closed loop, as you can see in the diagram here. What happens is the thermal oil coming from the boiler you have just seen, typically around 300 degrees Celsius, enters the ORC evaporator. Here, the heat is transferred to the working fluid, which vaporize and expand through the turbine, generating electricity. After the turbine, the vapor passes through regenerator first, where we recover some of the internal heat, and then it goes into the condenser where it's cooled down and turned back into liquid. Once it's condensed, the fluid is pumped back into the cycle and the process starts all over again. So the whole system is completely sealed, is a closed loop, as I said, that is designed to be tight and durable. That means there is no need for air reclassification, and the fluid top-ups are minimal, almost negligible, I would say. The system can be designed to work in power-only mode or in CHP, combined heat and power mode. It really depends on the plant priorities and client needs, whether to focus on maximizing the electrical efficiency or on producing hot water alongside electricity for any thermal user on site or any heat off-taker, district heating, whatever. When we are aiming for maximum electrical efficiency in power-only setups, we have a condenser. We can have a water condenser, but also a dry cooling with air cool condenser that are designed and manufactured in-house in TURBODEN. And that will help to avoid water consumption as well. Here, let's have in detail the differences with steam turbine. Of course, now I think it's clear that we don't use water. We have an organic fluid. And at TURBODEN, we have built a lot of experience in this area. We really understand the properties of these fluids, how stable they are at high temperatures, how flammable they might be, and so on. Simply because we have tested and worked with more than 10 different fluids over the last 40 years. So now, from a thermodynamic point of view, the biggest difference is that the steam needs to be superheated to work properly in a turbine, while that's not necessary for organic fluids. When organic vapor expands in the turbine, it always stays dry. there is no condensation, no liquid formation, and that's a big deal because there is no risk of blade erosion, which is something that can happen in steam turbines. We all know if pressure and temperature are not perfectly controlled. That's a risk. And those properties, characteristics, takes also has also some consequences, practical consequences, because steam systems are very sensitive to operating conditions and also water quality, I would say. So water treatment plant is always required, is a must, and that brings extra cost due to water and chemicals consumption mainly. Also, steam turbines operate at high pressure, so they need to be constantly monitored by skilled, trained, and certified personnel. On the other hand, ORC systems are fully automatic. They don't need anyone to be there watching over them. They just run on their own. So when you look at operational costs, all these translates to a more cost-effective system in favor of ORC turbines. Also, ORC are very flexible. They can automatically adjust power output based on changes in thermal input or ambient conditions. That makes the system really efficient. Maybe we can talk a little bit more about flexibility. If you take a look at the graph here, it compares how electrical efficiency behaves at partial load for both systems. What's interesting to notice is that when ORC is running at, say, 50% of the load, it still maintains about 90% of its nominal efficiency. Even when the input drops as low as 30%, efficiency stays around 80% of the nominal one. Steam systems, on the other hand, they don't handle off-design conditions nearly as well. I would say their efficiency tends to drop off much more sharply when they are now running at full load. And so flexibility is a big advantage in favor of ORC and makes ORC turbogenerators, I would say, a great fit for application where the thermal input isn't always constant. And I think that's the case for waste to energy application, where you may have fuels with a calorific value not really stable. So yeah, I think that's about it. Maybe we can now jump into a real case with Alex.
Thank you very much, Alessandro. ORC technology has been with biomass to energy for a long, long time, and now it is starting to participate, and it's fully participating into the waste to energy, and we hope we can implement it much more in the future. The success case that we are about to introduce now, it's Brook Energy. It's one of our two references in the UK. It's a 10 megawatt thermal input system with a 2.33 megawatt electrical gross, 1.99 megawatt electrical net power generation. The feedstock is it's RDF from 12 to 16 megawatt per kilogram, and the moisture content is up to 35. With levels of ash from 15 to 25. So it's, as you can see, a very challenging fuel. This is what we call in the UK a small waste incineration plant, meaning the 3 tons per hour is it's the limit that it can process, which means around 25,000 tons per year. technology, as I will show you will show you later. It was a step grade with a Horizon Plus thermal oil boiler. And okay, also it's a CHP ready, which means that it can have a possible cogeneration with hot water for the industries around. Once we have talked about this, let's see it in the video. How does it look like? We will start with an overview of the plant here. As you can see, this is an outdoor installation. Since the height of the boiler that you can spot on the left side, it's not a critical point because, as its name says, it's horizontal. You don't need a high building. You can stay outdoors, or in case you have a higher building, you can want it to put indoors. You don't need a higher building, okay? In front of the thermal boiler, you can also spot the combustion chamber. And on the left, you can see the chimney with the thermal oil system and the flue gas cleaning system. These elements that you see at the bottom are the air coolers from the turbine, which are situated right over the turbine building, which is the only one that it's not outdoors. Okay, so this is an overview of the plant. Let's go now to see component by component. Okay, here is the first, let's say, the first part of the installation is where the trucks unload the RDF, and the selected system is a top loader. This is the system we selected, even though in some cases the client prefers moving floor or moving floor silos. We are okay with both systems. We think that the top loader is very easy to handle, low consumption, and perfect for this kind of mixture of fuel. And it couples perfectly with the conveyor that it needs to follow after the top loaders. Here in the next video, you can see these 3 top loaders from the bottom side and the RDF being transported. This is one of the biggest expertise of my colleagues on the Bianna business. This is what they have been doing for a living during the last 30 years, and is transporting fuel and conveyors, intermediate silos. Okay, they are very, very good at it, and this gives me the idea of how we need to manage correctly the fuel in this installation. We have an intermediate silo, which is around 5 to 10 minutes buffer. Why are not we feeding directly the combustion chamber with this conveyor? Because we need stability. We need a regular waste flow stream into our combustion chamber. Otherwise, it would not be easy to maintain the correct combustion mixture and to maintain the output of the thermal power that we will give to the boiler, and therefore we will give to the ORC. Okay, so after these 2 elements, the buffer silo is connected what we call the main conveyor, and you can see at the following video. This main conveyor, it has a steep angle, and it ends on the automatic feeder, what we call automatic feeder, which is a double flap feeder that drops the fuel inside the combustion chamber. Okay, this is also a very critical component, since it avoids the fresh air, the oxygen, to be in contact with the atmosphere. Very important, so we don't have backfires, and we have a regulated and with the exit oxygen in the combustion. Okay, once we have seen these elements, we go to the next one where we can see the heart of the heat power generation. This is no secret for anyone who is in contact with this kind of plants. This is a step grade. It's an air-cooled step grade. It's where basically the fuel and the RDF is burning. But it has to be designed very carefully since it has to be IED compliant. What does this mean? It means incineration directive compliant, either in Europe or the UK. It means that after this stage, this is a first stage of combustion, it needs to have a second stage where we have to keep the combustion gases during 2 seconds over 800. So we can finalize the combustion correctly, okay? The norm also, it's very strict with this because emissions and what we are releasing to the atmosphere is critical in this plant, and of course it's critical in this business. So it's provided with 2 auxiliary burners that only work when this temperature is under 800 degrees. Also, our system is provided with artificial control combustion system, which allows us to have a real-time data and contact of what is happening into the combustion chamber. So we can control the flame front, and also we can control how much of an unburned RDF could come into the de-ashing system. And talking about the de-ashing system, we go to the bottom ash extraction. As I already have explained to you during the Horizon boiler video, one of the challenges of the RDF is the high amount of inert, of an unburned particles. That's why we have selected a very strong system able to manage up to 25 to 30% ashes in the system. The bottom ashes are the ones that we are collecting from the combustion chamber. And as you can see, it has a chain which is submerged into the water, and it's able to drop the ashes into a single point. Okay? So we continue with another important component, which is the boiler. Horizon boiler, I have already explained how it works. There's no much more explanations to give here. You can check it here on real life. And of course, for that potential plant buyers or promoters who are interested in knowing how it works on real life, we would like to invite you to see one of our facilities. Okay, then we have the thermal oil system, as Alessandro have already explained. This is one of the difference between a larger plant where the steam is the heat carrier. Here we have the thermal oil, which has 2 pumps that drives the thermal oil into the ORC unit and back. Also, it's provided with this storage and expansion tank that you can see at the picture, and the heat surplus system in case we have standby. We have these air coolers that you see on the bottom of the image. Finally, regarding the Bianna supply in this site, we have the flue gas cleaning system. In this case, we have chosen a ceramic filter, which allows us to filter the particles that we still have on the combustion gases on that stage under 5 milligrams normal cubic meter at 6% reference oxygen. It's not only this, because this is a train of cleaning system. We also inject calcium carbonate and we inject limestone in order to remove acidic gases, heavy metals, VOCs, in order to get the strict emissions limit that we find in the UK and, of course, in the European Union. Okay, so time now to see the electrical power generation, Alessandro.
Sure, thanks. Shall I get the
No,
video
I
myself?
do it for you.
Okay, perfect. Thanks, Alex.
Okay.
Let's enter. Yeah, perfect. Let's enter in the ORC building. That's an indoor installation housed in a building that's about 14 by 22 meters and roughly 7 meters high. I will stop the video here. Yeah, just to show you on the left side, you see the evaporator, this long heat exchanger, and there's a pipe where the pipes from the thermal oil boiler are coming from outside the building into the evaporator. And then on the right, you have what we call the cold module with the turbine, gearbox, generator, and the condenser. So there is a pipe taking the vapor from the evaporator to the turbine where the expansion happens, and the turbine is coupled to the gearbox and the synchronous generator for the power generation on one side, turbine rotating at 3000 RPM, and on the other side, the turbine is connected to the big heat exchanger. That's in this case is the water condenser, where the vapor exiting the turbine is condensed. On the just on the side of the condenser, you see there is a pump. Pump is located in a around 4 meter deep pit that you can spot covered by a grating floor and an access stairs. Yeah, for maintenance. Yeah, so very, I would say, compact and simple installation. The key feature is that the whole system operates at low pressure, which adds to the safety and simplicity of the design. To streamline installation on site, all main components are pre-mounted on skids. You see this red frame here, where all the components are mounted, as well as the electrical panels that are pre-cabled in our workshop. So in the next video, maybe Alex, I know I can do it.
Yeah, I can do it.
That's fine.
Okay.
I think it's starting now. Yes. Here we are outside the building, of course. On the top of the building, this is a water-cooled solution. So the working fluid in the condenser is cooled down by water, and the water then is cooled down with water cooling system, and it's a closed loop of closed circuit of water with air coolers that are placed on the top of the building. As an alternative, we can have, as I said earlier, dry cooling of the working fluid directly with air cool condensers that are designed by and manufactured in-house by TURBODEN. And I think that's all that for the virtual tour. I hope this was interesting enough, but I think it's time now maybe to connect with Glenn Brook to see live this installation. Yeah, here you are. Hi, Glenn. How are you? We can't hear you. I think your microphone is off.
No, we cannot hear you, Glenn.
Can you hear me?
Now.
Perfect.
Good. Excellent. Okay.
Hello, Glenn. I see
Hi,
that
how are you?
we're fine, and we
Good.
see that you have a nice like English weather day.
Always. Yeah,
Okay, Glenn, can you talk us a little bit about Brook Energy?
certainly. In its various forms, I have been doing waste to energy and biomass to energy since early 1990s. So we we have been active in this field for some time. Um, we have At the moment, operationally, we have three waste wood biomass plants running on steam, and we have now obviously built this plant, which is RDF plant running under a SWIP permit, so it's 3 tons an hour, generating 2.4 megawatts of electricity. The plant is going to be connected to a district heating network, hopefully later this year, and we will be heating in the region of 12,000 houses in extra airport and the extra science park, and so on. So we are uh, continuing to develop that side. Alongside this, we have a reasonably substantial waste company, so we burn all of our own waste. We're not importing waste at all at the moment, although we have plans to build another plant shortly, and for that one, we will start importing waste.
Alessandro, any question from your side?
Yes, so you already spoke about the next development in your facility, but about this one, how were things on site during the execution of the project? What's your feeling now that everything is started up?
We are running fairly well. Obviously, these plants take a while to commission and to settle down. Um, um, we are now getting used to it. We are burning at times we're burning a much lower grade fuel than Bianna specified, which is really good. And we have, I think, plenty of spare capacity within the plant if we want to go beyond the SWIP permit.
Alex, I cannot see if we have any questions from the audience. Do you see any of them?
Yeah, but it looks that they are more for us. If you want, we can ask something else to Glenn. Glenn, I guess after this we will have people from the sector interested, plant promoters, to go and visit the plant. Would you be happy to?
Obviously, I am more than happy to show people what we have here. Yeah, I am very proud to show people.
Okay. Okay. Alessandro, any other question from your side?
No, I'm looking now at if we have some question from the audience. Let me check. Okay. Here is the Q&A section.
Glenn, this district heating you will connect in the future is for the surrounding industries. Am I correct?
It's mainly for housing,
Okay.
domestic use. We are very fortunate here in that the local council have decided to use district heating. I think the final aim is to have almost 20,000 homes connected. We obviously, as I've just said, we have Exeter Airport will be connected. The industrial area around the airport will also be connected. We also have the industrial estate here where we're based. We use a small amount of heat on site, but most of our power generated during the daytime, in fact, all of our power in the daytime working week will go to our own on-site business.
Okay. Okay, we are already exceeding on time, and we still have to do the Q&A section. So, Alessandro, if you agree with me, we know Glenn is a busy man. We already taken a lot of his time. So, thank you very much, Glenn. Hope to see you soon there.
You're very welcome.
Okay.
Thank you, Glenn.
Yeah, take care. Bye.
Take care. Bye-bye. Okay, so it was very nice that we could connect. There's always these potential technical problems, mainly with the connection. But even though it was not the best weather day, we were able to connect. We are happy about it. Should we proceed to the questions?
Yeah, actually, there are a few for you, Alex.
Okay.
Actually, one is related to what is your plan in regards to the non-biogenic, therefore not renewable fuel?
Okay. This is true regarding the waste to energy systems. Approximately 50% of the feedstock is what we call biogenic. It's cardboard, it's organic. Okay, so this is technically renewable. This is CO2 neutral. So it's something we usually forget about, that the waste to energy industry, it's partially renewable. Okay, what are we doing with the other 50% of the feedstock which come from fossil, which is not CO2 neutral, such as plastics? Okay, I think we have to put in value that these kind of plants, and then the authorities know about it, are very close, as Alessandro said, to the waste origin. Therefore, we are saving a lot of CO2 in the transport of this fuel. So this is a big difference between the bigger sites. That's why they are potentially not being included on the energy trading system. Once said, we are aware of this. Bianna is aware of this, and of course we have a plan about it, which is CCS, which is carbon capture. And Bianna offers this service. We are ready to install it in any plant that is requiring it. And I strongly believe that the waste to energy sector, which is critical for society in the 4 points Alessandro has related before, needs to be close to CO2 neutral. So it's something to look at in the future. And yeah, we got a plan for it.
Okay, maybe there are a few that I can answer quickly. Does the air cool condenser are made by TURBODEN? Yes, we do air cool condensers in-house. We have big facilities in Turkey, and we do many of those for geothermal plants, which is one of the application we have in TURBODEN. Which district heating supply temperatures are possible and viable? Talking about district heating, we can provide hot water. Typically, district heating works with 90 degrees, 100 degrees Celsius. Maybe that was a question for Glenn. For his case, I think we will provide 90 degrees Celsius hot water. And that's the same we have in many applications, CHP power plants that we have in biomass with within our references.
There's another question about hazardous waste. Mm, this
Ah,
techno-
yeah,
yeah,
this
this
one.
yeah, this is a very interesting question because hazardous waste, there's a big debate on how much it can be recycled or not before waste valorization. Of course, we always say that waste valorization is complementary to the recycling. Okay, so it's not an enemy, it's an ally. Then there is some fuels which calls hazardous waste, which are doesn't have a lot of options. Okay, like hospital residues, hazardous. This here we have a step grade. Usually this is with a rotary kiln technology, which also in Bianna we hold this kind of technology, and the rest of the site would be the same as we have seen. I mean, as long as we are able to burn in a rotary kiln with a different conditions on this kind of hazardous waste, it will be connected to a Horizon Plus boiler, and the Horizon Plus boiler will be connected to an ORC turbine. So the answer is yes. There is. We have the technology. It's not the exact technology in regards to the combustion.
Yeah, talking about the fuel, there is also another question related that you might be willing to answer. Chlorine limits on the fuel specification. Is there any chlorine limits?
Yeah, in principle, we establish 1% of chlorine limits. It needs to be under 1%. Set this, okay? We are all very scared from chlorine because what chlorine provokes is corrosion. Okay, set this. This is something that happens more in the steam system. Okay, in the superheaters, we reach temperatures above 450 degrees, which let's not get technical here. This is something to explain from my colleagues of technical department. But basically, when we go over these temperatures, that's where we start to have corrosion in the superheaters. Okay, that's why these superheaters have cladding, Inconel, whatever. In this case, we have to say that we have the automatic cleaning, so no particles are corroding the the coils, but also since we have thermal oil up to 315, the temperature on the pipe is not never over 350 around. So we are not in these dangerous temperatures that can cause corrosion due to the chlorine. So yeah, the limit is 1%, but if you have a higher content, okay, let's sit and talk about it.
Okay, this question, I see that it has a lot of voters. Could you confirm if ORC technology can be applied also in larger scale waste to energy projects of 30, 40, 50 megawatt? Well, maybe here I can answer. Technically, it's feasible, definitely. And I think from the ORC perspective, but also I think on the boiler side, also because we can always go modular. Here it's a trade-off between cost and benefits. And also I will say we really think in TURBODEN and Bianna that small decentralized waste to energy is really the trend for the future because it solves a lot of problems. It helps community, it helps industries, and it's a smart solution. So we believe the future is there. Technically, it's feasible, and maybe it has also some benefits in terms of cost. Of course, when you reach economy of scale, going larger, you can also overcome all the extra costs that a steam system may have. So it has to be checked. Of course, there is no technical limit.
Okay, there is a question here that is linked to what you're saying, Alessandro, which is what are the possible scenarios that waste to energy are excluded from emissions trading scheme? maybe miss that part. Okay, we didn't go specifically into it. I think it's very high probable that either UK and the European Union will put waste to energy into the ETS for 2028, because this is a debate that is on the sector. The sector is also open to it because it wants to have good reputation. Okay, so if it doesn't happen in 2028, it will happen 1 or 2 years after. Said this, as we explained before, there is a limit that are established either in the UK or in the European Union, the threshold. In the UK, according our information on we have seen and listened in the congresses, they're going to establish a limit of 25,000 tons of CO2 per year. What does it mean? That any waste to energy plant that goes over these 25,000 tons per year will stop being a small, what they call in the UK, small emitter. Therefore, they will have to pay the taxes for the CO2 emissions. It will not happen under this threshold. What does it mean? That these plants will likely not be included on the ETS scheme, neither in Europe, where we think the threshold will keep on the 20 megawatt. Therefore, yeah, it will be more bankable.
Okay, so there are a few questions, of course, about CapEx and OpEx. And I think that's not really the forum to discuss those. We are happy, of course, to enter into discussion for each project. It's always difficult to provide a CapEx that it's valid for all the projects. So better to get in touch. We'll be more than happy to do that. Maybe this one about calorific value of the fuel you use, Alex.
Yeah, it was one of the slides, 12 to 16 megajoule per kilogram for this site. We can go further, up and down, but then there's something we have to study. Okay, but yeah, we can go on different values. There is another question, and then we should be finishing soon because we are about 1 hour with exceeding the limit. Which is the smaller system we can provide. This is something we can check depending on the project. Now we have other reference in the north of England, in York, which is 5.5 thermal megawatt, 1 electrical megawatt. Is one of is the other side we have in the UK. So Alessandro, one last question.
Maybe this one. I think we answered most of them. What is the required flue gas temperature into the boiler?
Say again, please.
What is the required flue gas temperature into the boiler?
Yeah, we work with a scenario of around 950 to 1050, 100. But this is more technical. It's always, I don't like to go very technical because this is for my colleagues, but yeah, this is the range, okay? But if you have any specific technical doubts, maybe we can have a separate meeting.
Okay, I don't see other question. Do you?
No, I think. Yeah. See, go on, Alessandro. Sorry.
Yeah, commissioning date for Brook Energy, I guess. Here it's only commissioning date.
Yeah, the site has been commissioned in September last year. Okay, and then soon after we have been doing the test with the turbine.
Maybe this one. You didn't mention in the presentation which percentage of the flying ashes may be captured by the rotary boiler.
No, that's a good question. I'm not. I'm sorry, but here you catch me. I'm not able to say how much are there. The idea, the main idea of the rotary boiler is not to catch these gases. Have it in mind. It's to be able to have a heat exchanger that that can eliminate these ashes from the surface of the heat exchanger, because the ashes, they are going to be whatever it happens, are going to be filtered in the flue gas cleaning system. I mean, it's not the goal of the
Yeah,
thermal boiler to reduce them, even though it does actually reduce it.
yeah, it's more the self-cleaning
Correct.
system. Okay, I think 1 hour. Um, that was the upper limit for the webinar. Um, I'm very happy. We had a lot of questions. We managed to answer, all of them. So I
And
think
of
it was
course,
maybe to have another one soon.
yeah, I see, because there have been a lot of questions and answer questions. Sorry about that. Feel free to contact us. You have our LinkedIn's, you have our contact. So yeah, feel free to just contact us so we can discuss about anything you consider important about this technology and potential projects.